to the subject only. Yeah. So just to start with, students are joining again. Yeah. What is an electricity? Yeah. Now let us see here. If you observe any matter here, any matter, all the forms of matter are made up of some molecules, right? Okay. And again, these molecules, okay, these molecules are made up of atoms. These are the basic things which are required to understand the Unit 1 concepts. So try to concentrate on these things here. And again, these molecules are made up of these atoms here. And if you take the atom, so and these atoms also are made up of protons, neutrons, and electrons. Okay, and this atom is very smallest particle of this substance here. And if you take these things here, you take an atom which is consisting of proton with a nucleus and neutrons with a nucleus here, and these and electrons also revolving around the nucleus in different orbits. Okay? And at the center of the atom, which is called as a nucleus, and it contains neutrons and protons at the center of the atom, according to Bohr Rutherford model. To take an atom here, at the center of the atom, so nucleus will be there. That nucleus is consist of particle protons. These are the protons and these are the neutrons. And we know that the protons maintain a positive charge polarity. It is having a positive charge polarity. And these white colors are neutrons, which doesn't have any polarity. So these doesn't have any polarities, which combinedly form a nucleus of an atom. Which combinedly form a nucleus of an atom. Right? So am I audible, Amma? This voice is clear to everyone. Please respond.
Yes, sir.
Yes, sir.
Okay, okay. So if any voice is breaking, and please let me know in the form of message and all those things. Okay, so that I can check. See, so according to, you might have studied about the Bohr's model in 10th class itself, and the smallest particle is atom, and this atom contains what we call nucleus. That nucleus will be having a neutrons and protons. So neutrons doesn't have any polarity, and the protons maintain a positive polarity. Okay, and again the atom is also consisting of electrons. These are electrons, and these electrons are revolving around the nucleus in different orbits or shells. Okay, so this is about the atomic structure. You might have studied about these atomic structure in 10th class level. Now see here, what I'm trying to say is that the electrons are revolving around the nucleus in different orbits, based on the elements in different orbits. So likewise, there are some number of shells will be there, and the shell is nearer to the, listen carefully, the orbit is nearer to the nucleus. The electron which is present in the shell, which is nearer to the nucleus, and it is strongly bounded by the nucleus. This electron is strongly bounded by the nucleus. That means even though if you apply any external energy to that particular electron, you may not detach that electron from that force of nucleus. Okay, and if you take another what you call orbit, okay, the energy levels are going to be increases here. Energy levels are going to be increases. That means energy levels means this. If you want to detach this electron from that nucleus, it requires less energy. So likewise, if we keep on moving from starting to ending orbit, let us say this is outer orbit. Outer orbit, if we, in the outer orbit, if the electron is there, it is having higher energy levels. Higher energy levels means the energy required to detach or remove the electron from the orbit is very less. Is very less. That means it is what we call weakly bonded by the nucleus. So to remove this is also known as a valence electron. To remove this valence electron, okay, the energy is very less. So this once this electron is detached from this outer shell, this electron is known as a free electron. This electron is known as a free electron. This electron is a free electron. Once if you remove or detach that electron from outer orbit, that electron is known as a free electron. So this free electron is very important to understand the okay. So the electron, how the electron comes from means, so the valence electron which is detached from the outer
Excuse
orbit
me,
is
sir.
known as a free electron. Yeah.
Sir, some students are waiting, sir.
Sai Kumar, tell.
Yes, sir. Some students are waiting. Please allow them to join the class.
Okay, I can't see any student, Amma. Let them join. Please, I request you to please the students try to join the class before 5 minutes. At least be on time. Up to 5 minutes I will allow. Otherwise, I won't allow because in the middle of the class it is not good to disturb. Okay, na? So any doubts so far here? What do you mean by a free electron, Amma? Atom is consisting of a nucleus. So nucleus is what? It is the combination of protons and neutrons. Neutrons doesn't have any polarities and protons have positive polarity. So positive polarity will exist at the center of the atom, and these electrons are revolving in different orbits around the nucleus. Okay. The electron which is present in the outermost shell is known as a valence electron. It is having high energy levels. It requires very less energy to detach that electron from valence shell. Once this particular electron is come out of that particular valence shell, it is known as a free electron. It is known as a free electron. So this is about the free electron. Once if you understand the free electron, you can easily understand what I mean by a current and all these things. And suppose, let us take an example of a copper atom. If you take a copper atom, and you know the atomic number is what you call 29. So what is the meaning of the 29 here? 29 is at the center we already discussed. It is a combination of the protons and neutrons. Protons and neutrons. So here there are 29 protons present here, and the 29 remaining electrons are there. Electrons are revolving in different orbits. And you know, the number of electrons which are present in particular shell is calculated by using the formula called 2n square, where n is the number of shell or orbit. Number of shell or orbit. Suppose if you take a first shell or first orbit, what is the n value, Amma? N value equal to 1. Okay, that means 2 into 1 square. So how many electrons are there in the first shell? Please respond. Sai Kumar.
Sir,
How many electrons are there in the first shell according to this formula? So number of shell is n equal to
2,
1.
sir.
2. So these pink colors, 1 and 2 electrons are revolving in the first orbit. So now come to the second shell. So according to the formula, how many electrons will be there? 2 into 2 square. So that means 4 into 2. How many electrons are there in the second shell? 8 electrons. Let us count here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons are present in the second shell on second orbit. Now, if you come to the energy levels, so the electron which is present in the first cell is strongly bounded by the nucleus. It is very difficult to detach that particular electron because it is nearer to the nucleus, right? And if you take a second shell electron, the energy levels is somewhat higher. That means it is somewhat weakly bounded by the nucleus. And suppose if you take a third orbit, then according to the formula, how many electrons should be there in third orbit? Please, anyone? You use that.
18.
Very good. 18. 18 number of electrons. See here. So there will be 18 number of electrons. Start from here. So, likewise, the 18 electrons will be there. Now, totally electrons here, 18 plus 8 plus again 2, only 28 electrons. But in copper atom, how many electrons are there? 29 electrons. And so, 1 electron will be revolving in the fourth orbit. And this shell is called a valence shell. And this electron is a valence electron. If you compare the energy levels, this electron which is present in the outermost shell, it is also known as the outermost shell. The outermost shell electron is weakly bounded by the nucleus. So whenever you apply a heat energy, heat means any heat energy or some electrical energy applied to a particular atom, these electrons may come out from that outermost shell and it becomes a, which electron, Amma? It becomes a free electron. Okay. The current will flow only through the free electron. So current may not flow through these electrons which are strongly bounded by the nucleus. So here, the free electrons are very, very important for understanding the concept of this current definition here. Okay. Now see this diagram. And if you take a carbon atom, 4 electrons are there in the valence shell or outer orbit or outer shell. Okay. Likewise, for different elements, the electrons which are present in the outer shells are different. Okay. So this is about the free electron. Once if you understand the concept of the free electron, and we can define a matter related to particular materials materials. All the materials are categorized into, one is conductor, another one is semiconductors. Conductors and semiconductors, another one is insulators. Insulators here. Here, if you take the electrical engineering, the total electrical engineer is talking about the conductors only. Okay. So now let us see what I mean by a conductor. See, conductor is an object or type of material that allows the flow of charge. Charge is what? Charge, I will tell later. The charge is due to a free electron only. Free electron only. I will come to this point later also. It allows the flow of charges in one or more directions. Okay? And the materials made of the metal are common electrical conductors. Can you give the best example for the conductor here? Copper. Copper. Next is silver. These are the best examples for the conductors. Okay? And before discussing about these things, let us discuss about the charge. Let me discuss about another concept here. Let us talk about the charge. What do you mean by charge here? Just now we have seen the valency electrons revolving in the outermost shell. Charge is a deficiency or excess of an electron. Listen carefully. Charge is a deficiency or excess of electron in an atom. The charge may be a positive or negative. The charge may be a positive or negative. The excess of electron is having negative charge. The deficiency of the electron is having a positive charge. Okay, so charge is related to the free electron concept. So that we have discussed about the free electron concepts. Now let us see here. Most basic quantity in an electrical circuit is charge amount. So the principles of electrical circuits starts with the charge. It is the most basic quantity. Now, it is an electrical property of atomic particles of which matter consists, and it is measured in coulomb. What is the units for the charge here? Coulombs. Now, charge E, it is represented by E for electron. On electron is a negative, and E is equal to, what is the value of the particular charge for one electron? 1.602 into 10 to the power of minus 19 coulomb. So this is the value of the charge, and it is having a negative charge, so you have to add minus here. Now what I'm trying to say is that, again I'm explaining here, this is in an atom there is a nucleus, there are some different shells. Outermost shell there is a electron, let us say one electron. As it is a excess of electron in an atom, which can create, say, which charge? Positive charge or negative charge? Excess of electron is having a negative charge. One electron, listen carefully, one electron is having how much charge? Minus 1.602 into 10 to the power of minus 19 coulomb. So indirectly, what do you mean by a charge here? Indirectly, charge is nothing but a electron. Negative charge is an electron. Okay, so that is the reason why here electron is a negative, which is having a negative charge, and that magnitude is equal to 1.602 into 10 to the power of minus 19 coulombs. And you know, while proton carries a positive charge of the same magnitude as electron. Magnitude of the proton is also same as that. One proton is having this much of charge, but it is equal to the positive value. The presence of equal number of protons and electrons leaves an atom neutrally charged. As these electrons and the protons are equal, so we can say the atom is neutrally charged. Okay, but when you apply some external energy, one electron is come out of particular atom, then we cannot say it is not neutral. Okay, so this is about a charge definition. So in our concepts, the point should be noted about the electric charge. So the coulomb is the unit for the charge. 1 coulomb means very large value, very large value. So if you take a charge, it is always, you can see in terms of micro coulombs like that. Suppose as one electron is having how much charge? 1.602 into 10 to the power of minus 19 coulombs. Okay. Suppose if you want to have 1 coulomb of charge, how many electrons you require? 1 electron is having this much of the charge. To make these many coulombs to 1 coulomb, how many electrons we require, Amma? How many electrons we can require? So 1 by this value becomes 6.24 into 10 to the power of 18 electrons are required to get 1 coulomb of charge. Okay. So that is the reason why the value of this charge may be in microcoulombs, nanocoulombs, picocoulombs, like that. Okay. Now another point should be noted that according to experimental observations, charges that occurs in nature. Now another point is the law of conservation of the charge, which states that the charge can neither be created nor be destroyed. Only we can transfer that particular charge. Thus, algebraic sum of the electric charges in a system does not change. This is law of conservation of charge. While discussing about the KCL and KVL, we will come to this law of conservation of charge. So these are the basic things which are useful to understand the concepts of current to voltage, like that. See, now let us take, this is a particular conductor, Let us take this is a copper wire. This is a what? A copper wire. As it is a good conductor, there are so many number of electrons are present in a copper conductor. So many number of electrons are present. 10 to the power of 8, 28 electrons per unit volume are present. So you imagine 3-dimensional. This is a conductor, a copper conductor, a copper wire. Suppose if you see electrical wire, if you remove the insulation, you can see a copper material inside. Am I audible, Amma? Please respond. Is it clear to everyone?
Yes, sir.
Yeah. If anybody having any doubts so far, we can ask. So far we have discussed about only a charge. What do you mean by a charge? So if you take a conductor, the number of free electrons are existing in a particular conductor. Now this is a particular conductor. What is this negative sign indicates? A circle inside a negative sign. What it indicates? Please respond. Anyone? Sai Kumar? I already said that it is a conductor.
Yes, sir.
Yeah. What is the inside a circle? The minus sign indicates what it means.
Neutrons.
Not neutrons. I already said that it is a negative sign. Neutrons doesn't have any polarity.
Electric current charge.
Charge only. It is a what? Electron. It is known as an electron, or in another way it is a charge. Electron or charge. So the diagram shows that there is a conductor, a normal conductor. A conductor, this is a conductor which is having number of electrons, or these electrons are known as a free electrons. What do you mean by free electrons? These electrons are not bounded by the nucleus. These electrons are ready to move whenever you apply an external energy to the particular wire or copper conductor. Suppose if you apply some external battery, and everybody knows battery, what do you mean by battery, plus and minus. I hope you might have seen. I will come to the battery diagrams. I will come to that point later. Before that, I want to show some batteries which are available. Let me show some batteries so that you can have a clear idea about the batteries. Yeah. Yeah, you might have seen this battery somewhere. This is a Panasonic battery here. So it should give you a DC supply. Direct current. DC means direct current supply. DC supply. It is a source of electrical energy in the form of DC. I will tell what is a DC later. And this is the symbolic representation. Symbolic representation. The device, a battery device, can be symbolically represented in electrical engineering. Each and every equipment can be represented symbolically, like one line, two lines are there. One line is longer than other line. Okay, so which indicates plus, longer line is plus, and this shorter line is minus. What is this? This is symbolic. Symbolic representation. Symbolic representation of which supply, Amma? AC supply or DC supply? Please respond. It is a symbolic representation of a DC supply. DC supply. So we can see this type of the batteries in watches, and these type of the batteries in alarm clocks. Okay, and this type of the batteries, you might have seen these batteries, which are the sources of DC supply. Are the sources of DC supply. And lithium ion battery. Yeah. Can you guess where can you use this battery, Amma? Please respond. Are you there or not? Sai Teja 109. Shravan 103.
Yes, sir. Yes, sir.
Yeah, where can you see this type of the battery, Sama? Have you seen this type of the battery anywhere?
Yes, sir. In
Where?
mobiles, automobiles.
Yeah, this mobile, this is a battery. How we are getting
Yes, a mobile.
the mobile here with the help of this battery. So the rating is this. Type of the battery is lithium ion battery. This is 3.7 volts. Rating is 3.7 volts DC here. So without this battery, the power supply is not available for the mobile battery. In automobiles, this type of the batteries are available. So these are the sources. This is the source. Wherever you write this symbol, plus and minus, what it indicates, Amma? DC supply. It is a what? DC supply. What is the example for the DC supply? Please respond. What is the example here? Battery. So wherever you see, this is the DC source. DC source. That means we are applying, we are connecting a battery. Suppose these are the two terminals here. Let me explain those things also. So these are the two terminals, right? So suppose there is a conductor here, copper conductor. This is a copper conductor, and one end is connected to anode, another one is connected to which one? Cathode. So this conductor is having so many number of free electrons. So this entire battery is going to be represented as this symbol. This symbol means battery. So this is the DC supply. So these are the types of the batteries here. Lithium polymer battery, lithium ion battery. This will be used in mobiles. Lead acid battery. Nickel metal hydride battery. Nickel cadmium batteries. So for different applications based on the different ratings, you can use these batteries. I will come to these capacitors and all those things later. Once if you finish this definition of the current, voltage, power, and you can easily understand the remaining things. Now, come to this point here. Now tell me, what is the symbol here? Plus and minus, one larger line and one shorter line, which is separated by some space. It is a which supply, Amma? It indicates? $145. 19145. Sai Teja 109. $109 is not responding. So meanwhile, I will ask the questions, try to respond. 107. Shravan.
Sir.
Yeah, what is the symbolic representation of that one? One short line on
Battery, sir. DC current.
Is it DC supply or AC supply?
DC, sir.
Very good. DC supply. To represent the AC supply, that is another symbolic representation. A circle inside a sine wave. This is AC supply. I will tell what is AC later. So for the time being, it is a battery. Okay. Now, what will happen if you apply a battery here? So this is a positive charge. The plenty of positive charge is present at this terminal. This is second terminal. Negative charge is present at this terminal. And you know, according to Coulomb's law, what is the force between one positive charge and one negative charge? So there is a charge Q1 and there is a charge Q2. According to Coulomb's law, what is the type of the force between these two charges? Type of the force. Can anybody tell me? according to Coulomb's law. Unlike charges, attract or repel.
Attract.
Very good. These are attract each other. These are attract each other. At the source, there is a positive charge, but in the conductor, there are free electrons are present. These free electrons are present. Okay? As these are the free electrons, which is having a negative charge. At the source, there is a positive charge. What is the force between them? Force of attraction. That means this positive terminal of the battery is trying to attract this electron, so that these conductor is connecting with the wires. These are some connecting wires. So let me erase. See, listen carefully here. See, this electron is having a negative charge. At the battery, it is a positive charge. So the force between them is attractive force. Which force? Attractive force. And this conductor is connected to these connecting wires. This is one connecting wire, this is another connecting wire. With this connecting wire, what is happening here? The electron is moving in this fashion. Okay? And again, what about this negative charge? This is a negative terminal of the battery, and it is also having the negative charge. What is the force between them? The two charges are having same polarities. What is the type of the force between? Repulsive force. Repulsive. There is a force of repulsion exists, so that it will try to repel this charge. So it is trying to move. So finally, what will happen here? The same electron is moving in this fashion. One electron is moving in this fashion. And in another way, you can also understand, as is a negative charge here, the negative charge is flowing in this fashion. Like that. That means finally what will happen here? Without applying any battery to the conductor, the charges are in stationary position. Stationary means there is no movement. Once if we apply a battery to a particular conductor, these electrons are moving. These electrons are what? Moving. In this circuit, it is known as a circuit. In this circuit. So now come to here. These are also known as charges. Charges are electrons are moving here. Once the charges are moving, here we have to define. Here we have to define one term called a current. What do you mean by a current here? So to define a current, here we have to take some cross-sectional area. It is a circular conductor. It is a what? Circular conductor. If you take a cross-sectional view, or if I take a cross-sectional view at this particular point, cross-sectional view means if you cut this conductor into two portions, and you can see this type of the cross-section. A circle type of cross-sectional view will be there. Now, while these electrons are moving in a particular direction in the loop, the electrons are crossing this surface area. Electrons are crossing this surface area. That means the charges are moving through this surface area. And if you take at this particular also, some electrons are crossing. So electrons are crossing here. Now, if you take a particular time, the time rate of flow of electrons, in a particular conductor through a cross-sectional area is known as a current. What is that? It is indirectly known as a time rate of flow of electrons or charges. It is known as a current. That is the what? Definition of electrical current. Okay. Now let us see this definition here. See, let us take this definition. Current can be defined as, listen carefully, the motion of charge, through a conducting material. It is possible only a copper conductor, easily possible in a copper conductor. It is defined as a motion of charge through a conducting material is known as a current, or indirectly time rate of flow or motion, both are same. Flow of electrons is known as a current, and it is measured in ampere. So the unit for the current is ampere. Very, very important amount. Ampere. Shortly it is known as a. Like if you take a practical situation, 2 ampere of current, 3 ampere of current, like that, 10 ampere of current. So these are some examples. And if you buy any electric device in a market, you can see a current rating of particular. Suppose if you take a fan, you can see the current rating of the fan is 10 amperes. So where A is for ampere, the current is measured in ampere. And it is denoted by a letter small I or capital I. I will tell the difference between small I and capital I later. The symbolic representation, letter representation is I, current. Okay, units are amperes. Next, there are 2 types of currents. One is direct current. One is what? Direct current is a current that remains a constant with respect to time. So irrespective of the time, the current remains constant. If you see in the form of waveform type, suppose if we take it with respect to time, the magnitude of this current is constant. That is the meaning of AC current. That means only always it is positive values. So suppose if you take it, this is y-axis and this is some x-axis. Above the x-axis only the current will be present. Above the x-axis only the current is present. Okay. With respect to time, the magnitude is constant. That is known as a direct current, and another current is alternating current. So in terms of waveform, and it is alternating current, the current that varies with respect to time. Suppose if you want to draw the magnitude of the alternating current I, this is known as I of t. With respect to time, see, for some time the magnitude is positive. For some of the time the magnitude is negative. So this is known as a positive magnitude and this is known as a negative magnitude. So the magnitude is going to be changing or alternating. Change or alternate. The magnitude is being alternating or changing. So it is known as a alternating current. For some time it is a positive, for other time it is known as a negative. So it is known as a alternating current. So these are the 2 types of the currents. Based on these waveforms only, you have to particularly categorize the supplies as a DC supply and AC supply. In DC supply, this type of the current is flowing, and in AC supply, this type of the current is flowing. Okay. So this